Okay, Aisha, here we go. I'm going to say again because this is like the infinite time I'm trying to record this. Okay, let's see. Look, you have the gradient and the y-intercept. You plug it into the equation that you know, the slope-intercept or gradient-intercept form, and you solve it. Once you solve it, you get something like this because you rearrange it and that's it. That's how you get it. That's how you solve for A, B, C, D, E, F. Okay? But there are a few things that I want to show you before just saying, oh, you solve it like this. Look, then I know that when you multiply this y by 5, it becomes 5y. Here you have it. And this 3 by 5, it becomes 15. But this 2x, when you take it to the other side, it becomes negative. So the thing that we have to do, or that we should do, is to leave always x positive. So 2x minus 5y equals minus 15 because we multiply everything times negative. It's like a punishment to everybody because x was negative. So everybody has to change the sign. Okay, and how do we find the gradient of this? Just to prove, just to double check that we did it right. Gradient is m equals minus a over b. So if it's minus a over b, the gradient is minus 2 over minus 5, right? If it goes like this, we have a positive gradient of 2 over 5. If you don't solve it, if you don't get rid of this negative, your gradient is still positive because you have minus a over b or minus minus 2 over 5. So both ways apply. Is that the second way is better, this one, okay? Why am I telling you this? Because if you have different signs, like in this case, you have a positive 2x and a negative 5y, your gradient, since you always multiply times negative, is always going to be positive. So when you have different signs, your gradient is positive. When you have the same signs, your gradient is negative. Why am I telling you this? Because I don't know if we saw this, but I'm going to show you anyway. When they give you the gradient, I mean, if not if we saw it, if I put it in the homework. So if you have the gradient and they tell you that it passes through this point to one point, we know that if the gradient is positive, it means that my values are going to be different. My signs are going to be different. So ax minus by over equals d, right? If my gradient is positive in this case, the gradient is 3 over 4. It's positive. So I have different signs, okay? Now, what should I do here? What we have to do is to say, okay, it's always a over b. So 3x minus 4b minus 4y, I'm sorry, equals d. And that's fast for us, but now we have to look for this number. How do we do that? Okay, we say if everything has to be balanced, it means that I'm going to multiply a 3 times an x and a negative 4 times a y. So I'm going to repeat what I have on the left side, 3 times x minus 4 times y. But what is the value in x and the value in y that I'm going to plug here? Here we have it. They're giving us the point, the coordinates, x and y. So 5 and minus 2. Once we solve this, it's going to be it. 3x minus 4y equals 15 plus 8. So 3x minus 4y equals 23. Oh my gosh, that 23, it doesn't look like a 23. Okay, look, there you go. So this means that if they give you the gradient and the y-intercept, you use your formula the way you know it, you solve for it, and that's it. Or, okay, yes, and if they give you the gradient in a point, the point is 5 minus 2, you plug the gradient with the different signs. Doesn't matter if it's A or B, but let's leave B negative always, if this gradient is positive. If it was negative, then A and B are both positive. You have it here just in case, okay, to check. And you say, okay, I have to have a balance. How does that work? Okay, that I have a number 3 and a negative 4 multiplying the coordinates x and y. What coordinates? The point that they're giving you. And that's how you get the constant or this value here. I hope this helps.